Artificial intelligence is currently all the rage with applications like ChatGPT, BERT, Copy.ai, DeepMind, and Mid-Journey. But, do you know what is under the hood of these applications? To start, all these popular tools are examples of generative AI. What is generative AI? Generative AI is AI that is designed to generate new data or content by learning patterns and structure within the existing data, then using this knowledge to generate new information. The key point is, to generate, thus its purpose is to create something new. Think through the implications of this and how it applies to the request you are making from an AI. Your first thought, this is cool that a machine can learn and generate something new from it. Your second thought, better check that last response I received to make sure it is correct. It is actually incredible that humans are building machines that can essentially think. The realization that machines can now develop new content adds a new perspective on many of the conversations or comments we hear about AI. For example, some people question if AI-generated images, video and audio are art? If other art was used as training data, is the AI-generated output still art? Is the use of training art plagiarism or is it inspiration? There are a lot of questions, but at the heart is a machine that appears to have crossed the line that separates following directions from thinking. It's an interesting philosophical dilemma, but we are going down a rabbit hole. Back to the question at hand. What's under the hood of that fancy new AI application you are using? To start with, they are all based on a foundation model. A foundation model is a large-scale, adaptable AI model. Some examples of foundation models are GPT-4, DALL-E, Stable Diffusion, Bloom and BERT. These models are trained on massive datasets, then adapted to a wide range of downstream tasks. Their training is often using unsupervised learning, with data such as text, images, and audio sources. Because the foundation model is learning on its own, it is learning patterns in data that are relevant to the model. That is, the AI is learning in a way that is relevant to the AI and not being forced into learning based on human learning standards. Using a foundation model as a base, anyone with sufficient knowledge can then further develop it for a specific use. Here are a few examples of generative AI applications that can be used as ideas for developing your own generative AI app. While at home, there are hundreds of generative AI applications to simplify and improve your life. Generative AI applications such as DishGen, AI Chef, Chef GPT, AI Recipe Generator, My Chef AI, Kitchen Engineer, Food AI, and Chef.ai are being used to plan meals and suggest recipes based on available ingredients, dietary needs, nutritional requirements, cultural desires, etc. It can also be used to suggest meals that save time, suggest alternative ingredients if you are missing an item, and be a real-time troubleshooter when something goes wrong. If you want to know more about AI in the kitchen, see our video on how AI can up your cooking game. For interior design, you can use a generative AI application, such as Room GPT, Mid-Journey, Photor, Interior AI, Architect GPT, and AI Room Planner to channel your inner Joanna Gaines. These applications can generate new styles and functions for interior spaces and help users redesign their homes based on their needs. There are hundreds of home design generative AI apps available on the internet today. Generative AI applications such as Once Upon a Bot, StoryWizard.ai, BedtimeStory.ai and ChatGPT are being used to create personalized bedtime stories based on a child's interest and experiences. These individualized stories help to foster a more engaging and educational experience for both the parent and the child. You can up your DIY home repair game using generative AI applications such as ChatGPT, Bard, New Bing and Perplexity.ai. These applications will provide the how-to knowledge needed to tackle most home repairs. In business, we are all familiar with how generative AI is being used for a multitude of purposes, including customer support, marketing content creation, supply chain forecasting, HR applications, fraud detection, etc. These tools are already prevalent throughout many industries. There are also several industries using generative AI for product discovery. In healthcare, generative AI has been prolific in discovery. It is being used to identify novel targets of activity, predict and catalog nearly all known proteins, create and validate antibodies. There are now a multitude of drugs in clinical trials that were discovered using generative AI. In aerospace design, generative AI applications such as NASA's Evolved Structures are designing spaceflight parts. The process of designing new spacecraft parts normally takes months to complete. However, using Evolved Structures, the design of new spacecraft parts is being completed in a few hours. In military training, generative AI is being used to create highly realistic and dynamic training environments for military missions. This includes virtual battlefields, scenario training, complex environment dynamics, and dynamic enemy tactics both on the ground and in the air. For chemical discovery, generative AI is being used to identify new molecules. For example, a group at IBM discovered then synthesized 3 new photoacid generator candidates in just 1 year. Normally, the process of discovery and synthesis takes up to 10 years to complete. While generative AI has a lot of gee whiz potential, it also has some limitations. For example, the quality of generated outputs may be too low for use, or the AI may hallucinate and provide an output that is not in agreement with its training data. Thus, a human-in-the-loop concept is needed for oversight of generative AI output. A generative AI's output is also limited in scope or creativity. This is because generative AI output is generally similar, but not identical to, the training data. The implication is that making large leaps in creativity will require that the generative AI application be augmented with human creativity in order to expand discovery beyond proximity innovation. The computational requirements for a generative AI can be immense. This is because generative AI systems require a large amount of data and computational resources for training. For example, 45 terabytes of data were used to train GPT-4. Yes, that is a lot of data. For comparison, the entire printed collection of the Library of Congress is estimated to be 10 terabytes. All this data has to be checked for authenticity, potential bias, and relevance prior to AI training. Large quantities of computational resources are then required during training to handle the large quantities of training data. In fact, there are several ideas for generative AI applications that are currently unachievable because computer processing abilities do not currently meet the needed requirements for data analysis. And finally, generative AI models lack explainability and interpretability. Generative AI models are often referred to as black boxes. This is because the model can be very complex and the process of creation non-transparent. This leads to authentication issues, especially when the generative AI is being used in new discoveries. So, a foundation model that has been extensively trained, then trained again using application-specific data, is what's under the hood of the fancy new AI you are using. The cool thing is that the foundation model is adaptability. Thus, any idea for a creative output can be used as the basis on which you can create your own generative AI application. I hope you enjoyed the video and found it to be informative. Thanks for watching.